Yes, you will not only see I, J, K, but you will also sometimes see EX, EY, and EZ. These are called basis vectors. Okay? Because irrespective of which coordinate system, remember we talked about the three different ones, which were and cylindrical. Irrespective of which coordinate system you're using, you do not have to use IJK because each of them have their own. So for example, in the spherical coordinate system, you will have R, theta, and phi hat. And in the cylindrical one, you will have R, phi, and Z. So instead of worrying about which ones you're in, people tend to just use E's for all of them. It's just whatever representative unit vector is being. Actually, does everybody know what a unit vector is, right? It is a vector with a unit dimension, and it only tells you the direction. In terms of vectors, just to make sure we all know, want to not assume. Yes. 1, 0, 0, 0, 1, 0, 0, 0, 1. Do you see how that works? It has a unit magnitude, but it only tells you the direction that that one belongs with. Everything else goes to 0. Ooh, yes. We have to talk about one other thing that there is a mistake in the book. And I'll tell you that I forgot a minus sign. Don't remember the equation, but there is a mistake in this book. It is the laws of sines and the law of cosines. The way these laws work is if you have any triangle, let's name this angle alpha, this angle beta, and this angle gamma from our trig 101. What is this side? Side that I'm making thicker. This side always is called A because it's opposite to the angle alpha. This side is called beta, B. And this side is called C because it's opposite to the side gamma. That's just conventionally how we've always done it. It makes it easier so we don't get confused. And also, do we remember from trig, angles are represented usually with either that or sometimes, because that gets confusing, they will also write it as, oh no, wait, hold on. My line's not straight. Does anybody remember from trig 1? That's how you would write them? Yeah. Okay. Does anyone remember the law of sines? Yeah. You are allowed to use any two of these parts to find whatever angle you're looking for, right? You don't actually have to have all three. We all know that from math, right? You don't actually have to have all three. Let's say you're looking for angle alpha, but you're given beta and the side A and the side B. You have 3 variables, you can use just that part, or vice versa. It's basic algebra. So laws of sine says and notice I'm not writing the magnitudes of B and C in here. Understand, it's always going to be da, 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 dum. I'm just being lazy because you're allowed to use that, right? If you don't put anything and it's a vector, this just means it's a magnitude of B, okay, right? You can write the magnitude of a vector as this or just that, means the same thing. And that's the mistake in the book. The book says plus. Yeah, that's the mistake. I forgot. Well, when I was writing it, I wasn't paying too much attention. So I think in the book, this one is a plus, but this should be a minus. Can anyone, do you guys want to guess what it would be for B squared? Take a wild guess. Don't say anything. Just write it down. Did everybody get this? Woohoo! And it's the same thing for C. You guys want to write it for C? Sure. Woohoo! Oh, before I forget, I should also tell you one other thing. Okay, unit vectors are funny. So I dot I is 1. However, I dot j is 0. Get it? Same thing with j dot j is 1, whereas I dot k is 0. In dot product, if you have I dot I, that gives you 1. If you have I dot j, that gives you 0. Anything that's against the number, it gives you 0. Cross products are opposite. So for example, I cross j will give you k. However, I cross I will give you a 0. I'm not going to write all of them down, but just know that, right? Oh, so can you guess what, okay, here's a guess. K cross K will be
0.
And let's pick out another one. K cross I. It will be J, but will it be plus J or minus J? Look at your smiley faces. So it's K cross I will be, using this one, positive J. That's all you have to remember. In a cross product, if they're the same, it'll be 0. In a dot product, if they're different, it'll be 0. That's all you need to know. That's nothing fancy. Yes.
Wait, I'm not understanding the smiley faces.
Oh, that just means when you have to multiply I cross J, it'll give you K. Oh. If you go the other way around, like K cross J, it'll give you a minus I. Oh. That's why there's a minus sign in the smiley face.
Got it.
So if you go this way, it's a plus face, you get a plus.
Yeah.
If it's this way, you will get a minus.
That makes sense.
Another interesting thing when we do vectors are called triple products. Have you seen those before? They are quite simple. Do you want me to tell you?
Sure.
Okay, so just like regular products, there are 2 types. One is called a scalar triple product. What do you think the answer should be for this? Done. And the other one is called a vector triple product. A vector. Done. That's why they're named that way. Do you remember when I was doing the I cross B here?
Yeah.
And it was 2? Yes? Can one of you want to hazard a guess what this one would be? It's a triple product. How many vectors should be involved? Woohoo! Yeah. So this, I'm going to write with blue. It is written as this. So what you do is you multiply B times C, like IJK, AX, AY, AZ, and then all of that. Or I could, and then multiply it again with, take a dot product again with A. Or I could teach you a simple thing. I know what you're going to ask me. Give me a second. It will work. All you do is matrix. Oh, one of them, it turned colors. Hold on. Let me turn it back. Okay. And the last is called a vector triple product. A scalar triple product had a dot in it. What do you think a vector triple product will have? Done. Do you want to write it on your own? And then I'll write it and we can compare. And I'm going to tell you a back to cab rule. Since I can never remember what order they all come in, and the order in vectors is very important. So this is how I remember. Back to cab. Back to cab. Oh, move this up. Oh, this one. That brings us to the end of vectors. Woohoo!